Welcome to Study Loop.
For this problem, we have been shown a definition for the characteristic function f sub s. Now, the characteristic function of a number has two possible outcomes. If the element is in our subset S, whatever that is, then if x is an element of that, then our characteristic function should give us a 1. If x is not an element of our set, then the characteristic function should tell us that the answer is 0. Okay, so if you can think of this as a belonging function, is it in there or is it not? Yes is 1, no is 0. And we're going to look at 4 different situations. For the first one, I'm going to pick my set to be the intersection of my two sets A and B. Okay, and what I want to show, here's my question mark, is this true? Okay, so let's take a look here. Let's suppose that my element x is in fact in that intersection. If it is, I would expect my answer to be 1. Okay, if it's in A and B. Okay, if it's in that intersection. Well, it should be 1. Well, if it's in the intersection of A and B, each of these is going to be 1. That works. If my element x is not in the intersection, if it's not in that intersection, then it should be 0. Well, depending on which one it is, either one or both of these values will be 0. If it's not in the intersection, it's either not in A or not in B or both. In either case, I'll be having a multiplication. It's either going to be 1 times 0, 0 times 1, or 0 times 0, depending on where x actually is. But in all of these cases, it does equal 0. So this does show to be true. Okay, next, let's look at the union. So my set now is the union of my two sets A and B. And I want to show that this is true. X plus f of x sub b minus f sub a of x times f sub b of x. Okay, so we're going to look at 3 different cases. First of all, if x is an element of the union, if it is in that union there, okay? And let's actually say it's in both. Let's say it is, I'm going to actually erase that for a second. Let's say that x is an element of A and B. Well, if it is, that's in the intersection, my value should be 1. Well, if it's in A and B, it's in A, that's a 1. It's in B, that's a 1. And it's going to be minus 1 times 1, which gives me 1. So that works. Now, what if it is in only 1? So it's either in A or B, but not both. It still should be in the union, so my value still should be 1. Well, if it's in one of them, it's either going to be 0, 1, plus 1, or 1 plus 0. The order might switch if it's in A or B, but one of these will be 0, one of these will be 1. And when I multiply those two values together, I'll be subtracting 0. Yes, it works. Now, what if x is in neither? X is not in A or B. It's not in A, it's not in B. Well, then it should be 0 because it's not in the union. And that math carries it out. So all of those zeros work. So our second case works as well. The characteristic function gives us what we expect based on this function right here. Okay, third, let's come scroll down a little bit to have a little more room. And my third one, let's look at the complement. So I'm going to say, I want the characteristic function when my set is the complement of A. And we want to show that that equals 1 minus f sub a of x. Okay, so let's let x be an element of A. If x is an element of A, then it is not in the complement. So my answer should be 0. And I get 1 minus, well, it's in A. Characteristic function gives me 1. That gives me the value I'm expecting. What if x is not in A? Well, then I would expect it to be 1 because it is in the complement of A. And since it's not in A, this characteristic function is 0. It gives me exactly the value I would expect. Okay, last one. Let's look at the exclusive OR. So this is going to be A with that little circle and cross, B. And I want to show that that equals f sub A of x plus f sub B of x minus 2 times this product. Okay, so let's take a look at three different cases. Let's say x is an element of both. It's in A and B. Well, this is an exclusive OR. So if it's in both, I want this to give me a value of 0. Okay, remember, exclusive OR means one or the other, but not both. So I want this to be 0. So if x is we're in both of them, first element will be 1, second one will be 1, and then it'll be 2 times 1 times 1, and that does equal 0. So it works. Okay, what if x is in neither? It's not in A and it's not in B. Well, again, I would expect that to be 0. And I actually do get that because it's not in A, it's not in B, and it's not in A or B. That gives me 0. Okay, so the last case, what if it's in one but not both? Well, that is the definition of exclusive OR, so it should be in that set. It should equal 1. And I'm either going to get 1 plus 0 or 0 plus 1, but one of them will be 1, one will be the other. And I end up with minus 2. And again, could be 1 times 0 or 0 times 1. The order depends on which set it's in, but I'm going to have both of those numbers there. And that gives me 1. So that is exactly what I expected. So in all 4 of these cases, we showed that the characteristic function gives us what we expect when we apply the formula given.